A Nobel Prize winner in physics warns the James Webb Telescope has discovered something that does not come from our universe. Roger Penrose claims that there was another universe before ours. It's possible that the ancient galaxies the Webb Telescope shows us are relics of this precursor universe. Other scientists are taking this daring theory even further, claiming that we have already received messages from a parallel world. Roger Penrose and his conformal cyclic cosmology, CCC for short, have caused quite a stir in recent months. The Nobel Prize winner in physics presented this alarming work in 2015, before the James Webb Telescope was even in operation. Penrose is considered a brilliant but controversial scientist. His work extends far beyond the boundaries of known astronomical and cosmological approaches. Penrose combines quantum physics with consciousness, the evolution of the universe with endless cycles of creation, and he proves that his worldview is absolutely compatible with existing mathematical quantities. Conformal cyclic cosmology is a theory that states that the universe as a whole did not begin with the Big Bang. The Big Bang only heralded a new cycle in an infinite series of creation and destruction. When our universe was born, there was nothing before it but a precursor universe. We are part of an epoch. It's hard to imagine that our universe, similar to Eastern ideas of the cycle of rebirth, is supposed to be the descendant of a precursor universe. Roger Penrose not only claims this, but also that a universe can bring certain properties with it from a previous life. This is similar to the Eastern idea of karma. The newly discovered ancient galaxies and impossible black holes could be such karmic phenomena. They have not been completely recreated, but are the aftereffects of an older universe. We are currently in an epoch of universal evolution. Until now, researchers saw this evolution as having a beginning, a becoming, and then an ending. No one could explain what came before or what should be after. The conventional answer was simple: nothing. But quantum physics teaches us that nothing is physically impossible. So, what's the answer? Roger Penrose says the solution is that a universe is a dynamic entity with a lifetime, like stars and planets. Universes exist in epoch, and each of these epochs begins with a Big Bang. At some point, the universe ends in a state of extreme expansion when all matter has been exhausted and physical forces have come to a standstill. Space collapses, the cosmos collapses, lingers for a moment in a state of perfect equilibrium, and then recreates itself from within. In this process, all the information of the previous universe is never lost. Similar to how souls take their experiences from past lives with them in the idea of reincarnation, the same thing happens to the universe. Since the blueprint for recreation is always present and does not have to be created first, matter is created much faster in the early epoch of a new universe than previously assumed. The universe rebuilds itself incredibly quickly from an invisible matrix. It's even possible that some gigantic black holes will remain during the transition between epochs. These black holes could serve as gigantic reservoirs of information from which the universe recreates itself. Does that sound crazy to you? Then I can tell you that Penrose's theories are mathematically and physically sound. Penrose is not just some crazy scientist either. The Brit is considered, along with Stephen Hawking, to be one of the best astrophysicists of our time. The idea of conformal transformation, the epoch, and the infinite cycles in the universe is absolutely compatible with the rules of Einstein's theories of relativity and other standard works in physics. Penrose presents ingenious new evidence. In 2015, he was declared insane. Some scientists even went so far as to suggest that Penrose had lost his mind when he postulated his CCC ideas. 7 years later, his work became more relevant than ever. The latest images from the James Webb Telescope showed galaxies at the edge of the universe that are so old that they shouldn't actually exist. Other images show black holes that are so massive that they must be billions of years old. According to our old cosmology, they existed shortly after the Big Bang. Both phenomena do not fit into our old cosmology, which posits that the universe emerged out of nothing 13.8 billion years ago and is unique. But they fit into Penrose's idea of cyclic cosmology. As early as 2015, Penrose suspected that remnants of black holes from the previous epoch are visible in the cosmic microwave background radiation. He argues that circular heat spots in the radiation could be evidence of the evaporation of black holes from an earlier universe. Now it even seems that some of these black holes may have survived the transformation from one universe to another. Once again, Roger Penrose was able to prove beyond doubt that this is computationally possible, and that this fact would even support his theories. The question remains as to what exactly the cosmic evolution from one universe to another looks like. Is one universe similar to the next, or is there some kind of further development taking place? Here too, Roger Penrose has an interesting view. He says that from epoch to epoch, adjustments and changes in physical properties and matter are possible. It is therefore quite possible that other universes were mirror images of ours, or that time ran differently within these spaces. The CCC supports the mirror universe. Isn't it incredible? Imagine a universe that is mirror inverted to ours, and in which time runs backward. According to Penrose's ideas, such a universe could have existed before ours, but it could also exist in parallel with ours. Scientists who support Roger Penrose's CCC argue that we must then also open ourselves to the idea of the multiverse. Quantum physics has long postulated that it's much more likely that our universe is just one of countless others within the multiverse. All possible types of universes can exist in parallel, sequentially, or cyclically. For example, a mirror universe could exist alongside ours and have measurable properties that are temporally and physically opposite to our universe. In this universe, time runs backward in contrast to our forward time. Scientists call this concept anti-time, and it's absolutely consistent. Findings from quantum physics confirm this model, and even Einstein's relativity equations cannot exclude a multiverse. Some researchers even suspect that the mysterious dark matter could, in fact, be particles from a mirror universe. The particles travel through a kind of threshold region, which we cannot measure, into our space and contribute to the gravitational effect here. Accordingly, there is probably no fixed boundary between the universes, but rather transitions and thresholds that currently elude our perception. However, traces of such thresholds could be present everywhere in the universe. We may have misinterpreted them so far. Calculations have now shown that an anti-universe could even help explain the extremely rapid expansion shortly after the Big Bang. The assumption is supported by the CPT symmetry, which states that the universe as a whole must remain symmetrical under the combination of charge exchange, C, space reflection, P, and time reversal, T. In this scenario, an anti-universe running backward in time would be the perfect complement to our universe. Such a model would create a complete symmetrical unit. This would not only perfectly explain inflation, but also phenomena such as dark matter. Hyperbolic space is a type of space-time geometry that directly follows from these ideas. Such a space expands infinitely and is negatively curved. The shape is reminiscent of an infinitely large saddle. In the idea of an anti-universe, hyperbolic space provides the structure in which our universe and the anti-universe coexist and complement each other symmetrically. A hyperbolic space differs from normal Euclidean geometry in the different behavior of lines and angles. In a hyperbolic space, parallel lines diverge further and further instead of remaining parallel. In Euclidean geometry, parallel lines always remain at the same distance from each other and never intersect, no matter how far they are extended. In a hyperbolic space, the negative curvature of space-time would be logical, and the boundaries of a universe would be open so that space and time can continue to exist beyond the observable area. You can imagine the transitions between the universes as pools of water that border each other. Due to the negative curvature, water and perhaps matter slosh back and forth between the different pools. If the water flows into another pool, however, it mixes with other conditions there. Hyperbolic space supports the idea of an infinitely expanding universe in which the geometry of space-time not only provides the structure but is the fuel of expansion and evolution. Combined with the inflation theory, the pocket universe is created. According to this, hyperbolic space is a unit, and the individual universes arise in the so-called pockets of this space. A hyperbolic universe could even explain how a universe can repeatedly create itself out of itself through curvature alone. The theory supports the idea of Roger Penrose's cyclic cosmology. When we discuss new concepts for understanding the universe, the steady-state idea must not be missing. In this cosmology, our universe exists in infinite time and looks the same at every point in time. There is neither a beginning nor an end in this universe. Expansion occurs through a continuous flow of matter. This matter could theoretically come from parallel worlds. We can use the example of the water basins again and imagine the idea as water being fed from one basin to another via nozzles. The resulting flow creates the impression of an expansion. However, the space is still infinite in time and space. The vortices and currents run out within the basin, and our universe also has discharges into other universes. The idea was developed as early as the 1940s by three American physicists named Fred Hoyle, Herman Bondi, and Thomas Gold. Initially, the theory was rejected because it was supposedly incompatible with the phenomena of cosmic microwave background radiation as a remnant of the Big Bang. However, current observations show that background radiation has often been misinterpreted in the past. Researchers have even found evidence of collisions with other universes in the radiation. This cosmic scar tissue could support the idea of the multiverse, and it could provide evidence that the background radiation has a different origin than the Big Bang. Subscribe now and never miss a new video.